Okay, we have two special cases of special right triangles. You should have these on your note cards, and I can't spell. Special right triangles. We're going to look at the first case, which is a 30-degree, 60-degree, 90-degree triangle. The sides are always in the same proportions here. Now this is on your note cards. This is Theorem 8.7. And if we have a 30, 60, 90-degree triangle, let's say that this is 60 degrees, this is 30 degrees, so of course that is your right angle. The longer leg is always going to be opposite 60 degrees because the longest leg is always opposite the biggest angle, right? So the longer leg is always opposite 60 degrees. The side opposite, if the side opposite 30 degrees is A, this is on your note card, the side opposite 60 degrees is A times the square root of 3, and the side opposite the right angle is 2A. So if we can figure out what A is, we can find any of the sides of a 30, 60, 90-degree triangle using this information that's on your note cards. So you always want to have your note cards with you. So let's say that we have a triangle ABC that is a right triangle. And so we know that this side is A, this side is A square roots of 3, and this side is 2A, but let's say that 2A equals 8. Can I find side AB, leg AB? How, Aiden?
Because since 2A equals 8, 8 divided by 2 is 4, and then so the shorter leg would be 4, and then the longer leg would be 4 times the square root of 3.
Good. CB then, if A is 4, CB is going to be 4 times the square root of 3. I think you'll find that this is usually pretty easy to work with if you'll keep your ratios, besides what those sides need to be in mind. Let me see if I think I have another one here. Let's say that we have a right triangle. So this has to be 30. This has to be 60. How do I know that that upper angle has to be 60? It's opposite the longer side. All right, so let's say that this side is 5. Hunter, what's the hypotenuse going to be? 10, because it's 2 times 5. And what is the longer leg going to be, Sarah? 5 square roots of 3. Good. The one that's got the square root of 3 is always going to be opposite the 60 degrees. Yes?
What do I do with this?
Just set them on the desk behind you and I'll pick them up in a minute. Okay, we have a special case of a 30, 60, 90-degree triangle. And that is when we have an equilateral triangle with an altitude. If it's an equilateral triangle, what does that tell us about the angles, Erin Rose?
That they're all the same.
They're all the same measure, and that measure is what, Caleb? If it's an equilateral.
60.
Okay, each of these is 60 degrees. And what do we know about all the sides? They're congruent. So if I drop an altitude to the opposite side here, we have a right triangle. what is this angle going to be? 30 degrees. So now we have a 30, 60, 90 degree triangle. So we know that this side is going to be a square roots of 3, this side is going to be a, and this leg is going to be 2a. So let's say that the altitude has a length of 6. Again, this is the 30, 60, 90. It's an equilateral triangle. I'm dropping an altitude. I know it's not drawn to scale. But this is 6. And I want to find the sides, the length of any side of the big triangle. All right. So 6 is equal to what, according to our... 6 is equal to a square roots of 3. Because it's the side opposite the 60 degree angle. Remember, this is 60. So how am I going to solve this for A? Michael?
Would you move A?
How do we solve this equation for A?
Why are we using A?
That's just, we could use any letter, but the theorem just uses A. Aaron Rose?
6 divided by 2 is 3, so if you have 2 times A as one of the sides.
Well, we need to figure out what A is. Can I solve this equation for A? Aiden?
You put 6, and then you divide that by a, square root of 3 equals 0.
No, if I divide both sides by A squared root of 3, I get 1. Daniel?
Divide both by the square root.
Divide both sides by the square root of 3. No different than if you had 3A or 2A. All right, so when we divide that, we get 6 square roots of 3 over 3. Multiply top and bottom by the square root of 3. I skipped a step, sorry. So what is A equal to? 2 square roots of 3 equals A, which is this side, which is half of the side of the triangle. What is this side going to equal to? 4 square roots of 3. So each side of that equilateral triangle is equal to 4 square roots of 3. Here we have another equilateral triangle with an altitude drawn, so this is 60. This time, let's say that the altitude is 9 square roots of 3. So 9 square roots of 3 is equal to what? If we think about our original triangle, that equals a square roots of 3. Can I solve this for A? How? Divide by the square root of 3. So what is A?
9.
If A is 9, what is 2A? 18. So each side of this equilateral triangle is 18. So let's just go through this again real quick before we look at the second case of a special triangle. 30, 60, 90 degree triangle. If this side is 5, what is this side? 5 square roots of 3. Notice 5 and 5. And what is the hypotenuse? 10. 2 times 5. The hypotenuse is 30. What is this side? 15. So the last leg is 15 square roots of 3. Okay. Pretty easy if you will keep in mind that the longest leg is always opposite 60 degrees, and that is a square roots of 3. You will see these special triangles a lot, again, especially when we get to trig. You'll see in pre-cal, you'll see these special triangles a lot. Yes, yes.
What year is that?
Harder than calculus.
Okay, we have a second special right triangle. Theorem 8.6 is a 45 degree, 90 degree isosceles. What does it mean if it's isosceles?
The 2 sides are congruent.
2 sides are congruent. So that means if this is 90 degrees, what's this angle? They're both 45 because the 2 acute angles have to be complementary. So that means these sides have the same measure. And the hypotenuse is always a times the square root of 2. Does it matter how we draw the right triangle? If this is my right angle and this is an isosceles right triangle, that means this is 45 and this is 45, then we have the sides A, and A square roots of 2. So if I have triangle EFD, or DEF, and this is if these are both marked congruent, if you see that these are both marked congruent, you know you have a 45, 45, 90 degree triangle. And say that this side is 12, DE is 12. What is FE? What's the length of FE? 12. What is the length of DF? 12 square roots of 2. Right? It really is easy if you keep in mind which sides correspond to which triangle. Let's look at one where we're given the. Let me see if I can keep that so you can see it. All right, if you know that those sides are congruent, what does that tell you about the triangle? It's an isosceles right triangle, so it's a 45, 45, 90 degree triangle. What if the hypotenuse is 10? How do I find the length of each leg? 10 equals A times the square root of 2. Now, how do I solve for A? Divide by the square root of 2. So A equals 10 square roots of 2, and I have to multiply the top and the bottom by the square root of 2. So we get 10 square roots of 2 over 2. So what is A? 5 square roots of 2. So just because you see that square root of 2 on a side of a right triangle does not necessarily mean it's a hypotenuse. Notice here the hypotenuse was 10. All right. We had a special case for the 30, 60, 90 when we had an equilateral triangle and we drew an altitude. We also have a special case for an isosceles right triangle when we have a square. What do we know about a square? What about the sides of a square? They are equal. And what is each angle? 90 degrees. If I draw a diagonal, what kind of a triangle do I get? An isosceles right triangle. So if you have a square with a diagonal and you know what the side is, you can easily without even having to think about it, find the lengths of the diagonal. Here's a square with a diagonal. So if I just mark one of these angles, those the same, and let's say that the side of the square is 12. What is the length of the diagonal? The diagonal is 12 square roots of 2. Very good.
Could you open that other one that you moved to the side?
Have a square. The sides are congruent, and this is a right angle there, so that means we know we got a square. Even if you're not told, if you see you've got congruent consecutive sides and one right angle, you know that you have a square. And the length of the diagonal is 10. Can we find the lengths of the sides?
Yes.
Ken, how would I find the lengths of the sides?
You would do 10. Well, you'd have to find 8, so it would be 10 equals 8 times the square root of 2. And then you divide both sides by the square root of 2.
Did we, or one almost like it, I think, didn't we? Was it the exact same thing, except we had a square instead of just a triangle? So what is A? Okay, so you should start seeing some patterns that help you solve these.